it's a floor, it's a rough floor, and it's a almirah placed here. So if I apply 15 Newton force, then just imagine the almirah is counterpacked. I mean, it doesn't move. That means what? The floor actually acts the same force. I mean, the same and opposite force act on that almirah. That is why the almirah doesn't move. Okay. Now what happened? If I apply, let's say 16 Newton force on that almirah, then just imagine the almirah moves. Okay, the almirah moves forward. I mean, the moves on the right side. Then actually what we learned in that case, that the static frictional force actually self-adjustable, right? So first of all, if I apply a 10 Newton force, then the floor acts 10 Newton on the almirah. That is why the almirah rests on the floor. Now if I apply 15 Newton force, then of course almirah, the floor acts 15 Newton force on the almirah. Okay. Now if I apply 60 Newton, just a little bit, okay, then the almirah starts moving. That means the static frictional force actually a self-adjustable force, right? And it has a maximum value that can resist that by force actually. So the maximum force of that static friction is called maximum friction of static frictional force is called limiting friction, right? So limiting friction means the maximum static frictional force that can apply the floor on the almirah. It is called limiting frictional force, right? Limiting frictional force. It is called maximum force of static friction. So if I overcome that maximum friction, I mean the limiting friction, then the almirah goes forward, right? Okay. Now there is a third case, is the rolling friction. All of you know what is the rolling friction. If a wheel rolls down on the floor, then the friction appears on the wheel by that floor, is called rolling friction. Okay. Now it's a task to do some problem, right? Number one, it's a problem, the previous year's problem on this NEET medical UG. So NEET UG, previous year's problem. A block rests the floor of a car. A block rests floor on a car, okay, and both moves. I mean the block and the car moves with the same acceleration. With the same acceleration. And if the coefficient of friction, that means coefficient of static friction, that means mu here. Okay. The coefficient of static friction is 0.15, then calculate the acceleration of the system, I mean the block and the car, right? Okay, so first of all, a block rests the floor on a car, both moves with the same acceleration, with the same direction also. So if the coefficient of static friction is 0.15, then calculate the acceleration. Okay, so first of all, what is the coefficient of friction, right? So actually, if I want to introduce a formula of the friction, just imagine it's a floor and a block. Okay. So if the block of mass 10 kg and another condition, if the block of mass 100 kg, then what will happen? Okay. So if the block of mass 10 kg, just imagine it's the atoms of the block and it's the white atoms of the floor, I mean the surface. Then if the mass 10 kg, that means the reaction force is somehow smaller, reaction, and the reaction force is somehow smaller, because if the mass is 10 kg, then the gravitational force acting on the block is quite less, and if the mass is 100 kg, then it's a quite larger. The reaction force should be larger, then the component, when the normal should be larger, frictional force should be larger, so that you can introduce the frictions force proportional to the normal force, because if the normal force is larger, then the frictional force should be larger, right? And if we introduce the equality here, so of course you should introduce a constant, the name mu. Mu means the coefficient of friction, mu, right? Okay. So now in that case, the actually earth pull the block here with the force mg, and the mg should be equals to the normal force, because the block doesn't move vertically, na? So ultimately N should be equals to mg. So F equals to mu mg in that situation, right? Okay. So now just back to our problems. It is actually so we want to calculate the acceleration of that system. Just imagine is a car. It's a car here, and it's the floor of that car, and the block rests on it with a mass m. Then what will happen? The block and the car moves with the same acceleration. I mean the block rests on the car. Now just imagine the block moves with an acceleration a. That means what? A force act on it, of course, because it's an acceleration. The force act on it now. So ultimately, what is the force? It's the force of friction that imparted by the floor of the car. So of course, the block has its mass m. So downward force, gravity, it's the mg. The normal force by the floor, it's n. So ultimately, the force on that block is actually frictional force, and that is the reason the moving of the car, that means ma. Okay. Now m means mu mg equals to ma. Cancel out. Mu means 0.15 according to our case, and just imagine g equals to 10 meter per second square. 10 here, so it's a. So a means actually 1.5 meter per second square. That is the acceleration of the system, I mean the block and the car. Okay. Now another example for JEE, the previous year's questions for joint entrance examination. So it is the questions. I just draw the diagram first, then I just explain the questions and then solutions. So it's a floor, and here is a pulley, a block with a wheel here, and a string connected the pulley through the system, and here the block of mass, let's say 5 kg. The mass of that cart is 10 kg, and the coefficient of friction, let's say 0.05. Okay, and of course pulley and the string is a massless. Okay. Now we have to calculate the tension of the string and acceleration of that system. Okay, so now just choose the system. So first of all, just choose the system as in the block. So ultimately, two forces encountered here on the block. It's a gravitational force mg. That means mg, mass of that block 5, and g means like 10. So ultimately 50 newtons. And the string just pull the blocks here with the tension T. And just imagine the block falls down with an acceleration A. It's actually our tricks. Now we just apply our tricks. That means the block actually fall down with an acceleration A. That means mg is greater than T. So ultimately, in the block case, the block situation, mg minus T should be equals to ma, and mg means 50 minus T equals to mass of that block 5a. It's the number 1 equation. Okay. Now just choose the system as that card. Okay. Now it's the tension of that string that pulls forward the card, and the frictional force mu mg here, because the mu in mg, I mean the gravitational force pulls downward, the normal force by that floor, it's a n. So ultimately mu equals to nmg, because there is a no vertical movement. So mu mg. So all total force here on that card. So the card situation, card here, and the block, card actually moves forward with an acceleration a, right? So card actually moves forward with an acceleration a. So that means T will be greater. So T minus mu mg equals to ma. So tension minus mu 0.05 here, mass of that card 10, and g, that 10 meter per second, mass of that card 10a. So ultimately T minus, if you calculate, it will get 5. T minus 5 equals to 10a. It's the number 2. Okay. Now just solve these two simultaneous equations. Nothing there. Just place it here. So T minus 5 equals to 10a. Now just these are two equations, cancel T and T. 50 minus 5, 45 equals to, just add it, get 15a. So a equals to 3 meter per second square. It's the acceleration. And just put the values of a in one of that equation. Let's say here. So 50 minus T equals to 5 into a. That means 3. So 50 minus 15, that means 35 equals to T. So tension is actually 35 Newton. Okay. So these are all the situations. Okay. So here is the stop. No, it's a good night.